Good morning and welcome to lesson 1 of science in our official start of the year into Amplify Science. Our first unit is called Geology on Mars. We're going to start a new science unit this year all about Earth and space science, the study of processes on Earth and in space. Now, Earth science is not just knowledge you could read about. It's also the process used to figure out that knowledge. You'll learn to see and investigate the world like an earth scientist would. This is a question as old as time itself. Are we alone in this universe? For eons, people have looked into the night sky and wondered, are there other things out there? Is there life beyond our planet? Now, today, scientists are using advanced tools to see if this is even possible and whether planets could ever support life besides our own. In this unit, you're going to have the chance to take the role of a planetary geologist. One thing planetary geologists will do is search for evidence that other planets may have supported life. You'll take on this role in this unit. As planetary geologists, you'll help the Universal Space Agency search for evidence that other planets could support life. So I'm going to ask you right now to make a prediction. What do you think a planet would need to support life? Answer your question in the Ed Puzzle pop-up now. Alrighty, our first vocab word of today. Habitable. If a planet is habitable, it means that the planet has the conditions necessary to support life. For example, I could say that the moon is not habitable because there's not a big atmosphere and there's not a lot of things on the moon that could support life. In other ways, I could say the Bay Area is very habitable. We have water, trees, food, and a lot of other resources, so there's conditions necessary to support life. We're going to look at different planets as a planetary geologist and try to make conclusions on whether that planet is habitable. Throughout the year, you'll be able to look up vocab words in the glossary to help you understand what they mean. You can always find this in your student sheets, which I posted right below this, or in the Amplify library. We'll go over how to use the textbook next week, but I wanted to link this just in case you needed to get ahead. Real scientists were looking for evidence that other planets were habitable in the past. Taking on the role of student planetary geologists will give us a chance to do some of the work real scientists do, and we will use what we learned to answer the questions on the next slide. And this is our big unit question. So by the end of the unit, we'll have our answer. After 11 lessons, 13 lessons, we'll know how can we search for evidence that other planets were once habitable. This is a little kickoff that I made describing the start of our unit. Hello and welcome. My name is Mr. Henrique, and I will be your science teacher for 7th grade. For today's lesson, we'll be going on a mission through space and time.
Today marks the start of your journey into becoming a scientist. Let's see if you're ready.
Activating scientific mindsets.
System calibrating. Minus 10, 9,
Preparing simulation.
7, 6, 5.
All systems are go.
3, 2, 1. Ignition and liftoff of Ares 1X. Testing concepts for the future of new rocket design.
This is your teacher speaking, Mr. Henry. Our destination is Mars. Once you're on the surface, take a look around, look at the landscape, collect some rock samples, then head on back to Earth. I'll see you on the ground.
Scientists are interested in evidence that a planet that is not habitable now could have been habitable in the past. Our search begins with our solar system, which is pictured on the next slide. Because Earth supports life, we'll want to search for evidence of past habitability on planets that are similar to Earth. If we would look at the map of the solar system, Earth is here. The further you get away from Earth, the less Earth-like our planets start to look. Because Mars and Venus seem a little closer to what we are, and then Jupiter doesn't look like Earth at all, Saturn even different, and these are our gas giants. For these lessons, we're going to tend to focus on the planets inside the asteroid belts. These are considered our rocky planets. The planets in our solar system that are farther from the Sun, such as Jupiter, Saturn, are very, very cold, and probably too cold to support life. Because these planets are mostly made of gas and ice, there's not anywhere for life to be, because it's just gas and ice. The 4 planets closest to the Sun, including Earth, we call these the rocky planets. Rocky planets are probably going to be a great place to start looking because the Earth, like the Earth, their surface is solid, so life has somewhere to live. A word that I've been using that I want to define for you is rocky planet. Any planet with a solid surface, such as Earth or Mars, is considered a rocky planet. If the planet's made out of gas, it is not a rocky planet. Mercury, Venus, and Mars are the most similar to Earth in some very important ways. Let's look closer. First things first, they are close to the Sun, so they get enough heat. They're made of solid rock, and they're relatively close in size. Earth is the largest of the rocky planets, Venus comes close, and then Mercury and Mars are relatively close in size as well. We're going to investigate this unit, how to search for evidence that other planets may have been once habitable. How does our understanding of Earth help us learn about other rocky planets? When scientists think of Earth as a whole, they think of it as a system. This is going to be another one of our vocabulary words. A system is a set of interacting parts forming a complex whole. The Earth system is made of parts called spheres. We have the hydrosphere, which is like the water system, the atmosphere, which is the air system, geosphere, which is like the rock system, and then the biosphere, which is where life occurs. These are our 4 main Earth systems. We're going to watch a student-made video that explains how is Earth a system.
A system is a group of parts that interact. Just like a human body or a machine, the Earth is a system made of parts. Scientists like to refer to these parts as spheres: the atmosphere, the hydrosphere, the geosphere, and the biosphere. The atmosphere is the mixture of gases that make up the air surrounding Earth. The hydrosphere is the water that makes up oceans, lakes, rivers, and more, including polar ice caps and other ice. The geosphere is the solid part of Earth, from its rocky surface to its iron core. Finally, the biosphere contains all the living things on Earth. Like body parts, the spheres of Earth interact and affect each other. Let's look at an example: volcanoes. Volcano eruptions are events in the geosphere because the surface land is changing and rock is being pushed out from under the surface. Volcanoes also expel a lot of gas into the atmosphere. Rainfall, which is part of the hydrosphere, often increases following an eruption, which also stimulates plant growth in the biosphere. Everything that happens on our planet is part of a complex set of interactions. The four spheres of Earth help support life on our unique planet.
What ideas and questions do you have about the Earth system? What are some other examples of systems that you can think of? Examples of system include the solar system, an ecosystem, a machine, the circulatory system, which is like how blood flows through your body. They're all forms of systems. And the definition we're going to use is a set of interacting parts forming a complex whole. So anytime you see a bunch of different parts of things moving together, working together, we're going to call that a system. Finding a planet that's similar to Earth can give us an idea about where to search for evidence of habitability. Because it's the closest rocky planet to Earth, we're going to go ahead and focus on Mars. On the following slide, you'll observe some pictures of cards in order to compare two parts of the Mars system to the Earth system, the geosphere and the hydrosphere. We'll start with the geosphere. The geosphere is the rocky part of Earth, from the soil at its surface to its iron molten core. Earth's geosphere shows evidence of Earth's past. Earthquakes, volcanic eruptions, rivers, and ocean waves all leave evidence of how Earth's surface has been shaped into the landscape we see today. The geosphere, I'm going to define it for you, is the solid part of the rocky planet, not the parent, the planet. Read these cards and I want you to think about this question. What are the differences and similarities between the geospheres of Mars and Earth? So we just read that earthquakes, volcanic eruptions, and rivers left evidence on Earth's surface. Let's read about Mars. The rocky surface of Mars shows evidence of its past. Where space rocks have hit the surface, they left giant round holes called craters. Huge volcanic landforms, including the biggest volcano in the solar system, have been built up from past eruptions that flow out of volcanic vents. Scientists study the rocks in the geosphere for any evidence of past or current water. What are some similarities and differences between these two geospheres? You're going to answer this question on the Edpuzzle now. Alrighty, we're going to move on now to the hydrosphere. The hydrosphere of Earth means the water system of Earth. Let's take a look. Earth's hydrosphere is the water that makes up Earth's ocean, lake, rivers, and ice caps. Within the hydrosphere, liquid water flows through streams and rivers down to lakes in the ocean. As water flows, it wears down rocks and changes the shape of the land. Earth is the only planet that we know of with bodies of liquid water on its surface. Let's take a look at Mars. Mars does not currently have bodies of liquid water on its surface, although it does have frozen water at its poles, which you can see in the picture. It has its own ice caps. One of the most important areas of Mars research is the search for past liquid water, and can we find evidence of that ever existing? Scientists search for this evidence in Mars rock formations. The hydrosphere definition that we're going to use is all the liquid water and ice on a planet. What are some similarities and differences between the hydrospheres of Mars and Earth? Go ahead and answer that on Edpuzzle. Did you notice that there are some similarities between the geospheres and hydrospheres of Mars and Earth? There are evidence that volcanoes once erupted on Mars, and it also has some frozen water at its poles. Given all of this, I think we're going to want to take a closer look at Mars for habitability. So today we've already learned a little bit of what planetary geologists actually do on a day-to-day basis. Now we're going to hear from a real planetary geologist who is using what she knows about Earth to learn about Mars. In this video, you're going to get a chance to meet Dr. Lauren Edgar, a real scientist, and just like her, you'll get to analyze real data collected by NASA. As you're watching the video, listen for answers to these questions. I will ask them at the end of the video. What are the two things that we need for a planet to be habitable? How does Dr. Edgar use what she knows about Earth to learn about Mars? So these are the things to be listening for. Two things that a planet needs to be habitable. And then how does Dr. Edgar use what she knows about Earth to learn about Mars?
My name is Dr. Lauren Edgar, and I'm a planetary geologist here at the U.S. Geological Survey in Flagstaff, Arizona. One of the key questions driving planetary exploration is, are we alone in the universe? To help answer that question, I'm looking for habitable worlds in our solar system, meaning environments that may once have had the conditions necessary to support life. Two of the main conditions needed for life are a source of energy and liquid water. Liquid water is really important because all life as we know it requires it. So it's the first thing to look for in the search for life beyond Earth. For over 100 years, scientists have been wondering whether Mars ever could have had liquid water. And as we've collected more and more data from Mars, we've realized that Mars is actually one of the most Earth-like planets. But it looks like there's some nice flat blocks in a few places, here. As a planetary geologist, I study rocks on Earth to understand the geology of other planets like Mars. My specialty is actually to look at rocks on Earth that have interacted with water, and then I use that knowledge from Earth to look for similar environments on Mars to figure out whether Mars may have once had flowing water. I'm here in Sedona, Arizona, about 30 miles south of Flagstaff. This area actually looks a lot like Mars and has some similar types of rocks and landforms. So because of this, it's a great place for me to collect samples and make observations that I can then compare to the geology of Mars. Down below me is a river, and it's a great example of water interacting with rock. As the water rushes over the rock, it picks up little individual sand grains and pieces of the rock that get transported downstream and eventually deposited elsewhere. Over time, these water-rock interactions will carve out a landform that I can observe, and it will tell me what to look for on Mars. If water's been carving rock for a very long time, it's possible to make a landform called a canyon. Canyons are deep and narrow landforms with steep walls that often have a river at the bottom. This is a great example of a canyon that's been carved by this river. As a planetary geologist, my job is to gather evidence at canyons like this and compare that to what I can observe on Mars. If I can find similar textures or patterns in the canyons on Mars, then that becomes strong evidence that water once flowed on Mars.
Dr. Edgar is looking for planetary evidence that there is liquid water in the past on Mars. She gathers evidence on Earth of how water interacts with rock and compares that to what she sees on Mars. Scientists who study these rocky planets, including geologists like Dr. Edgar, often compare the spheres of other rocky planets to those of Earth, which is the rocky planet we know the best. The key concept on the next slide provides a summary of some of the important ideas we learned today. Number 1, Earth, Mars, and other rocky planets can be thought of as systems. These systems are made up of interacting spheres that can include the geosphere, the atmosphere, hydrosphere, and the biosphere. And to go over that one more time, geosphere rocks, atmosphere air, hydrosphere water, biosphere life. That concludes today's lesson. I'm going to, in the Edpuzzle, there should be another couple questions that will just retest your knowledge and make sure you got the big takeaways for today. Other than that, have a fantastic day. And get excited. This is our start of 7th grade science officially. Bye-bye, y'all.